Okay, as promised, we're going to do another learning check for limiting reactants, and then we are going to talk about yield. That is, how much are we actually going to make? Looks like I have an extra C here at the end. Not sure how that came about, but let's look at this question here. Given the following reaction, suppose we take nitrogen and hydrogen and we make ammonia. Calculate the amount of ammonia possible, right? Calculate the amount of ammonia that's formed when 2.5 grams of nitrogen reacts with 2 grams, of hydrogen. All right, so I set this up on the next slide. We're ready to do this. First thing we're going to do is we're going to convert these grams to moles, right? We've got mass in grams. We've got molecular weight in grams per mole. And we're going to calculate moles, and then we're going to calculate, well, what we think we can get, okay? So I'm going to set this table up every time. So first of all, the mass that we had for nitrogen looks like it was 2.5. 2.50 grams, right? And the mass we had for hydrogen was 2 flat, 2.00, right? And the molecular weight of nitrogen is 28. And the molecular weight of hydrogen is 2, right? 2 grams per mole. And so 2.5 divided by 28 is, get my calculator out here, 2.5 divided by 28 is 0.0893. 0.0893, right? And 2 divided by 2 is 1. Okay? And so now we'll make our little L, and we'll say how many moles of ammonia can I make, right? So it's moles of ammonia that I'm looking for. Moles of ammonia that I'm looking for. How do you spell N? Moles of ammonia that I'm looking for. And here I've got H2. I've got to use H2 here. And this is N2, right? And so let's use this. I know I've got 1 mole of hydrogen, and it looks like it's 3 to 2. 3 to 2, right? There's my 3 to 2 ratio. And I've got 0.089, 0.0893 moles of nitrogen here. And it looks like it's a 1 to 2. 1 to 2 ratio, right? So I'll take that times 2. This times 2 is 0.1786, and this is 2/3. I can see that, right? 0.667. This is the smaller number, so that's the amount of ammonia I'm going to be able to make. So I'll put that right here because this is my table, right? 0.17886. And the molecular weight of ammonia is 17, right? And so I can get the mass of ammonia from that by multiply by 17. 3.04. 3.04 grams of ammonia. And there is my answer. That's how much ammonia I can make. All right. So let's move on now to the next topic, and that's calculating yield. So I just calculated how much I could make. I could make 3.04 here, right? But what happens if my reaction was imperfect and I lost some and I only made 2.5, right? Well, that wouldn't be all of it, right? So the question would be, what percent did I actually make? So the theoretical yield is how much you could make. The actual yield is how much you do make when you go into the lab, right? And the percent is just the actual divided by the theoretical. That's it. The actual divided by the theoretical, okay? So let's do this problem here. I think I have enough room here to do it just under the balanced reaction. Try to write real slow here so that I'm neat, which is not easy. I think I'm given masses. Now I'm given masses. I better make that an M. Grams. Molecular weight. Grams per mole. And moles. Right? So, all right, on a space shuttle, lithium hydroxide is used to absorb exhaled CO2 from breathing air to form blank, lithium hydrogen carbonate, lithium bicarbonate. according to this reaction, it looks like, right? And I think that's balanced. 111, it is. What is the percent yield if 50 grams gives that many grams of that? Aha, okay. So let's come here, and I've got 50 grams of lithium hydroxide, and I've got all the carbon dioxide I could possibly want, so we don't need to do the limiting reagent here. 50 grams of lithium hydroxide, and we'll figure out the molecular weight of that right now. Let's go here. Periodic table. Periodic table. Lithium is 6.94. Oxygen is 15.999. And hydrogen is 1.008. So lithium hydroxide is 6.94 plus 15.999 plus 1.008 is equal to 23.947. 23.947. Okay, and so that's going to give us 50 divided by that is about 2.088. 2.088 moles, right? So I'm going to now say, all right, well, how many moles of lithium hydrogen carbonate is that going to give me? So I'll come over here, and I'll say I've got my moles of lithium hydroxide, but I got to convert it to moles of lithium hydrogen carbonate. All right, it looks like it's 1 to 1. See that? There's a 1 here and a 1 here, so that's 1, 1. And I started out with 2.088, right? So it looks like it's going to end up being, well, son of a gun. Looks like it's going to end up being 2.088, right? Because it was 1 to 1. See these cross off? All right, and molecular weight of this looks like I'm going to be adding a CO2 to it, right? So it's whatever this is plus CO2, right? So it's 23.947. I don't add all those things up again, so I'm just going to add 23.947 plus carbon, which is 12.011, plus 2 times 15.999 equals 67.956. 67.956. And you know what? I'm going to Google that just to verify. That's exactly what I got. 67, I got 67.956. Okay. Save trouble, right? 67.956, and I multiply that times 2.088 equals 141.89. 141.89. That's how much I can make, right? But that's not how much I actually do make. How much do I make? I make this much, 72, okay? So my actual is 72.8. And my theoretical is 141.89. That's how much I could make. And I have to multiply that by 100 to get my form, right? And I'm going to divide. And I'm going to get about 51.3%. 51.3%. And that is my percent yield.